Alright, so my apologies to everybody. I'm having to continue section 7.3 just for a little bit longer. I mean, we don't have much left. There were two types of logs that I did not cover in the first part, okay? The first one is called common log. Alright, so common log. This is the log that's on your calculator, okay? It just says log, okay? That does stand for common log. This is always a base of 10. Always base 10. Alright, and let me give you a couple of examples here, okay? So if I give you an example of log 3x equals 2, okay? Notice that the base is not pictured, okay? Common log base won't always be pictured, okay? So you have to just know that that is base 10. So this is base 10 of to the second power equals 3x. And at that point, you could solve this, okay? 10 squared is 100 equals 3x. We divide both sides by 3, and we get x equals 100 over 3, okay? Alright, so that's just one example there, so just be careful. If you see log by itself, that means that's common log, which means that is always a base of 10, okay? So there's our first one. Our second one is called natural log, okay? Natural log, okay? This one is on your calculator as ln. I know, and I always get the comment of that seems a little backwards. Shouldn't it be NL? That is true, okay? But it's been ln as far as I've learned it, okay? And so ln stands for natural log. I think why it's written as ln is it's logarithm natural, okay? And so that's why they put it that. So ln is always base e, okay? Now there's that e again. We covered this back in 7.2, okay, when we had continuously compounding interest. So this is going to keep coming back. This is going to be a reoccurring thing, okay? So don't forget that ln is always base e. So let me give you an example here. Alright, so if we have ln 5x equals 3, notice that the base is not given, okay? So what you have to do is you have to remember that this is base e, so this will be e to the third power equals 5x. Now, on your calculator, I have a TI-84, so you have to hit second ln to get that e to a certain power, so e to the third power comes out to 20.085536692 equals 5x, okay? So that was just that e to the third power equals that big long decimal, okay? Alright, the only thing left to do is to divide that by 5, and we get x equals, and this time I'm just going to round it to 4 decimal places just to save some time here, 4.0171, okay? And so that is my answer for that one, okay? So there are two there that the base will not be pictured, and so you have to be extremely careful, okay? Now I want to give you one more example. We'll call this Hawks example number 1. I always get students that are a little confused about this one, okay? It says to evaluate the following logarithmic expression without the use of a calculator. Alright, so it gives us ln parentheses 1/8 root of e to the 6th power. Alright, now, again, I'm going to read the directions one more time. It says evaluate the following logarithmic expression without the use of a calculator. Okay, so again, it gave us an expression here, which means I need to set this equal to x. Now, based on the two prior examples right here, we see ln. What base is ln? That would be base e. So e to the x power equals the 1/8 root of e to the 6th power. All right, now the key to solving this is being able to rewrite that as a fraction, as a fractional exponent, okay? Now, let's not forget when we have fractional exponents like, for example, 8 to the power of a over b, okay? The a is going to be my power, and the b is going to be my root, okay? That is so important, okay? The root is on the bottom, the root is on the bottom, the root is on the bottom. I cannot stress that enough, okay? So e to the x power equals e. Now, how am I going to write that 6 and that 8? What number is going to go on top? Well, the number that goes on top is supposed to be the power. That should be 6 over 8. Okay, now notice this is an exponential form here, okay? Are the bases matching? Yes, they are. All right, so we get x equals 6 over 8, which that reduces to 3/4, which is my answer. X does equal 3/4. Okay. I always like to cover that one with my students. You're going to see one like that in Hawks, so don't freak out. And when you see fractional exponents, don't freak out either. Okay, just don't forget that the top number is your power, and the bottom number is your root. Okay. All right, now let's do one more. I know I said that was going to be the last one. One more though. Okay. This one's going to involve common log. Okay. So it has the same exact instructions, except this time it says we could use a calculator if necessary. Okay. So it says to solve the following logarithmic equation. So this time they're going to give us an equation using a calculator if necessary to evaluate the logarithm. Okay, so we have log of 7,608 equals 2x. All right, so if I try to convert this to an exponential function, okay, that would be 10 to the 2x power equals 7,608. All right, trying to determine a common base right here is going to be impossible, okay? You know, because this can't go any lower, and you can't get this base equaling 10. You can't, okay? You just can't. Because 10 to a certain power is not going to get you 7,608, okay? So in this case, and this is why it tells us we can use a calculator, okay? I'm just rewriting the problem one more time, okay? We're actually going to punch in our calculator. We're going to put log 7,608 and hit enter. Okay, so we were solving that part right there. 3.881270504 equals 2x. Now all I need to do is divide both sides by 2. Okay. And we get x equals, and again I'm going to go about 4 decimal places here, so 1.9406, and that is my answer.